Okay, I'm just going to check if we're back. Yeah, we are. Okay, and we're back. All right, so we've added the first part of our project is done. The first refinement we've made is we've talked about our plane. Again, the plane is going left and right for our male pilot, and now we're going to add an island. We're going to define the island sprite, and we're going to make it so that it moves down the screen. So it looks like it's moving down the screen. The delta y, so the change in direction of y is going to be 5. So it's actually going to go 5 pixels at a time as it scrolls down the screen. Okay? And then again, we're going to also do something like when it hits the bottom of the screen, your island sprite is going to reset to the top of the screen. So this is the island sprite. We've already handled our avatar, and now we're going to deal with our island. So let's take a look at that with mpisland.py. Oops, that's not what I wanted. I wanted this. So it's mpisland.py. Again, it's in your code archive. So you've got our plane. The plane class is here now still, right? Here it is. And now we're adding another class. We're creating our class for the other sprite we're writing, which is our island sprite, right? And if you notice, we're going to load up our island.gif file. We're going to convert it to a Python and Pygame compatible file. We're going to define our border, our rectangle around the island. Then we're going to call in our constructor when it actually gets called. When we create or instantiate the object, we're also going to reset it. Okay. We're going to also set up when it's instantiated, the object is instantiated, we're going to set up our dy value to 5, which is the speed of the island moving. Okay. In our update function, we're going to change the center of the island. So every frame, we're going to move the island down. That's what plus equals to this dy value is, down 5 pixels. And we're going to do a boundary check. Here's our boundary check. If the top of my sprite, the top of the island, is greater than the screen height, which is the height of the screen, which is 480 pixels, right? Then what we're going to say is we're going to call the reset function, right? So this is the reset function. We're going to say the top of my sprite is going to go to 0, the top of the screen, again. And then my center X, where it appears from the left to the right side of the screen, is going to be a random location from the top left corner of the screen to somewhere the size of the screen width. So it can be anywhere along the top of the screen it's going to appear with this random function. That's what this is going to do. Okay? The rest of it is pretty much the same as for our first iteration, our first refinement, except this time we're defining both a plane sprite and an island sprite. So both those sprites are being defined. We're instantiating them, right? We're including the island sprite and the plane sprite together. And if you notice, in this particular case, I'm defining the island sprite first, and then the plane sprite, in hopes that the group method or class is going to layer the island sprite below my plane. Not always the case, however. You're going to see that might be an issue. The clock is still going to be 30 frames per second. Our mouse is going to be set the visibility is going to be set to false, and the rest is exactly the same. We're just going to update all of our sprites at once. We're going to create that update function. So let's take a look at now how this one works. Okay, so I'm going to run it. Okay, so I have my plane, like we defined in my previous iteration, and my island sprite is going to come at a random location at the top of my screen. Now, so far it looks like the right side of my screen, but there it is. There's one here. And if you notice, my plane looks like it's flying over the sprite, not underneath the sprite, right? Because, again, I was hoping to get this effect. If I change the order, and again, this is our group here. If I change the order of how I've written this, and if I put plane here, and I go island here, sometimes what this will do, not always, right, is layer my plane underneath my island, right, like this. See, it didn't work, right, just the way things are defined. So in order for me to get my my objects in the layered order that I want, there's something called a different function, like I mentioned last week, called ordered updates instead of our group function. Okay? So I would replace this group by something called ordered updates, right? And then, if I wanted my plane to fly underneath my island for some reason, okay, and I play it, here's my island, now it's going to go underneath. I can actually tell it exactly where to go underneath my island if I really wanted it. Now, it's silly, but I wanted to illustrate the fact that you can control the order of your layers using ordered updates. Oops. I'll put it back the way it was. And you know what? I recommend to you that instead of using the group method, that it's better for you to use the ordered updates or layered updates method for grouping your sprites together. It's a better method because it gives you control of which sprites are layered on top of which other sprites. Okay? So again, I'd recommend ordered updates over group. Okay? Well, let's leave it the way it was just for the sake of the exercise. Okay. Everything else remains the same. So now we've built the second thing, our island. And it does look like the island is actually coming down at us. But all that we're really doing is we're doing a couple things here. We've got our avatar, right? So let's go back to fireworks for a second, right? And let's just kill this, and we'll destroy this too, right? And we'll load up our avatar for the plane. So here's my plane. And I'm also going to load up my island. So here's where we can actually draw out some of these, or sketch out some of these plans. Here's my island. If you notice, my island is exactly the same. It's just an island. And if I zoom into my island also has no information here on the side. But it's pretty pixelated, eh, guys? Take a look. Like, this is really, I could probably clean this island up even more. Right? So whoever created this island, it's probably Andy Harris, the guy who made this thing. I mean, he could have cleaned this up a little bit more. He could have made this island a little bit closer from a crop perspective. It's not perfect, but it works for our purposes, I think. Right? So that's the island. And that's our plane. Now, just from a simulation perspective, if I take my island, here's my island sprite, and put it on my background, here's my background, okay? And I take my plane, and put that on the background too, right? Here it is. And my screen width and everything else isn't correct. Let's just make it what it's supposed to be, modify canvas size. I believe it's 480 by 640, if I'm not wrong. Make it long. Okay, so there's our plane. So if you notice, what's happening is this sprite that's going to move down the screen, here it is moving down the screen as an example, and I'm pulling it down with my mouse in this particular case, right? But it's moving down the screen 5 pixels every frame, so it looks like it's moving down, where the plane is staying stable here in the middle of the screen. Reality, all I'm doing is I'm limiting my plane movement to left and right, and I'm moving my sprite, the island sprite, and all it's doing is moving in a downward position until we do our boundary check. And again, I'll move down until I do a boundary check with the bottom. And once the top of the sprite gets to the bottom of the page, it resets. It resets it way up to the top. And I think I'm not sure if I crashed my. Oh, there it is. It resets to the top, and it kind of appears at the top of my page in a random location across the top. That's what this thing does. And then it starts coming down in another position. But the plane really is still limited to the same area that it is. Any questions around this? This is the key thing when it comes to scrolling. So we got a scrolling object that's moving down the screen. It looks like it's moving down the screen. Now, from our assignment number 4, right, obviously we'd have to, instead of it, if we're going to replicate this, the island would have to come from this side, wherever the plane's direction is going. So if my plane is going, if the scrolling is going from right to left, the island is going to come from the right direction, from the easterly direction, if you will. And the plane's got to be pointed in that direction. So that's some changes we have to make to the code in order for our sprites to move correctly, to give the illusion of moving right and left. Okay, so those are the changes you have to make to your project. Okay. And we've talked about this code already, so I'm just going to flip through. Island illusion. We add transparency. We crop close, it says. Small targets are harder to hit, right? Small targets are harder to hit. Move down to give the illusion that the plane is moving up, right? That's what we're doing with the island. And we randomize to give the illusion of multiple islands. So instead of having one island, and then we have multiple islands come at the same time because it's coming from different places on the top of a screen. Yes. But theoretically, you could instantiate more than one island, and you can have multiple islands on the screen at the same time. We can do that as well. Let's look at clouds. So this is the next part. Now we've added in our objective to get points, and now we're going to add clouds. These are our enemies, if you will, as we build up our project here. Okay, so you go to mpcloud.py. Okay, here's mpcloud. Again, we have our plane sprite. We haven't changed that one. Our island sprite, same, right? And now we're adding our cloud sprite. Okay, so we're doing the exact same kind of thing with this one. We also have a reset function for this class because, again, if it gets to the bottom of our screen, we want to change the position to the top of the screen again. We want to say, okay, when it gets to the bottom, reset the cloud to the top. So this is the bottom of the cloud. We reset to 0, which is the top of our screen, right? The x coordinate, so where it appears horizontally across the screen, is going to be random. But so is the y coordinate in terms of our dy. So how fast it moves down the screen. The cloud itself is going to have a random speed. Some clouds are going to move faster than other clouds. That's what this is going to do, right? And also, the direction that it's going to move in, right, is going to go from -2 to 2. It's going to create a random range of -2 to 2 from a dx perspective. So actually, our x-coordinate, instead of just staying stable and wherever it's coming from, it's going to drift either to the right or the left by 2 pixels. Okay, depending on our random number that we're going to gain from this. That's what this is going to do for the clouds. Okay. So here's our check. If the top of the cloud, right, gets to the bottom of the screen height, then we're going to reset it. We don't care if it goes off the screen. If it goes off the screen, it's still going to hit at some point that 640 pixels or the screen height, right? It's still going to hit it, but it's just going to be off the screen. We don't care about it. If the cloud's off the screen, we can't collide with it because our plane is limited in motion to being on the screen, right? But we're still going to do a check. So when the cloud goes off the screen, it hits our screen height, or the bottom part of the screen, it's going to reset itself to the top somewhere. Okay? And it can happen. If you notice, the drift can take the cloud off of the screen, slowly. Okay, so that's kind of normal. All that's normal. Here's our single cloud sprite that we're going to create. And we're going to group them again. In this particular case, I've used ordered updates to layer everything properly. Island first, then on top of that plane, and then on top of the plane, the clouds. Because the plane should fly, theoretically, under the clouds, right? Not on top of the clouds. Although you could put it the other way around. You could put a cloud here and then plane on top of the clouds, flying over the clouds, right? That's possible as well. Everything else remains the same. Let's take a look at that. Okay, so here we go. Our plane sprite, a little bit of drift in this cloud here that you saw. Right here it is. This is slowly drifting. I got my island sprite. I'm flying underneath the clouds, but over the island. Right? Underneath the clouds, but over the island. Right? And I've done that with my layered images. Now, so it looks like the clouds and the island are moving towards me. Right? And there's only one cloud now. It's got one cloud and one island. Okay, here we go. So this is a good start, right? Again, I'm starting off, my screen is 40 by 480, and my drift, the X drift, so horizontal drift, this is what this really is, it's -2 to 2, is only 2 pixels, okay? But if you notice something, my my y value, which is how fast my cloud is moving down, could be as slow as my island, not slower, because if it was slower than my island, that would kind of look funny. The island would be moving faster than the cloud, right? I mean, you could have a slow-moving cloud, but when you're in a plane, typically you want the clouds to be at least as fast as your island, right? And up to double the island speed. So it could be up to 10 pixels per frame as opposed to 5. So actually quite faster. If I change these values, it's -2 to 2, and I make them -5 to 5, I can make a much faster drifting cloud right or left. So let's check that out. So it's going to drift much faster to the right or left, right, depending on which way it's going to go. Here it is, right? This one's kind of straight down. Here's a much faster cloud there to give the illusion of the clouds moving in different directions. There, that's a pretty good diagonal direction. So again, it looks random. It creates our random environment, if you will. Okay? So you can play with some of these values. Again, if we were going to do this on a side-scroller perspective, like so we're going to replace some of these assets with other assets, you'd have to change these, the direction. Instead of the dx value changing for drift, you'd probably want the dy value to change for drift and the dx value to stay like the dy value. You'd have to swap these values out, right? Because you want the images to come from your right or your left. You don't want them to come from the top. In past iterations of this assignment number 4, some people have kept the clouds coming from the top of the screen while you're scrolling to the left and right. I will dock you marks if you do that. It doesn't look right. It looks like there's stuff coming at you from the top, but meanwhile you're doing a side scroller, right? The stuff in a side scroller primarily should come from in front of you, right? Because you're moving this way in one direction, right? It shouldn't come from the top. Okay. Now it can if there's some extra rain or something like that that's coming at you in your side scroller. It's coming down from the top. In addition to stuff coming in front of you, you can do that kind of effect. But typically, all your enemies or obstacles or even things, the objects that you're going to pick up should be coming from in front of you. Okay, let's shift back. So we've talked about the clouds and the class here. We use the random range again to kind of create a randomized environment. So the environment, so the cloudscape, the place where you're flying, the sky that the plane is flying in, my mail pilot, it's going to change in a random order. It's still going to create that feel that you're flying in an atmosphere that can change. Gives you more challenge. We've already covered all this. Now we're going to add some sound and collisions. So collision detection, I agree with this one. It's critical to gameplay for sure, right? And sound effects, you link them with collisions to give the user feedback to say, okay, I've actually collided with something. I've done something here. Because sometimes if you don't have the proper sound collisions, the game doesn't seem as realistic, right? Now, in this particular case, the collisions and the sound that we're using, it's kind of homemade sounds. Like the user, if you listen to the sounds from Mail Pilot, they go, yay, you know, yay. That's what it sounds like. So if you actually run this code, and I encourage you to do that for Mail Pilot, he's actually created his own sounds. But I encourage you to get some more better sounding sounds or sound clips for your collisions. So this is key too. They do provide a natural test to make sure that the collision works. So instead of you having to output collide, like in a text box somewhere or in a console, if your sound works as things collide, you know you collided. The two objects collided. And it says here, collisions and sounds are often built together. I want to warn you here that if you make your sound clip too long, right, like sometimes I've seen in the past, there's been some creative types that like, really cool sounds that come from different places that are a little longer. They last about a second. That's really long for an explosion. Like boom, 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 as an example, would be an explosion. And if you go into the cloud and it's that long, you could start another explosion again very soon because there's going to be another cloud or another obstacle that's going to be coming at you. So I'd encourage you to test the sound and the length of the clips that you're getting to make sure that they're appropriate with the game that you're making. Sometimes you also have to create a delay. So after your sound is created, you create a delay before your object, your ship, is brought back into play, right? So you make that big boom, boom, boom sound of, example of a collision or an explosion, but you don't bring your avatar back into play immediately because otherwise you can collide with other objects before the sound of the explosion is finished or your animation of the explosion is done. And you don't want that. You want to wait until the whole effect is completed before you re-engage the player. Okay. So, again, you're going to create a plan for your sounds. Each sound object will be stored as an attribute of the plane object. Okay? This is key. So you're going to preload your sounds up as your plane object is instantiated. Okay, they're not going to be global variables that you're going to load up. They're going to be loaded as your plane is. Each object has their own sounds. Right? Let's take a look at mpcollision.py. So again, we're going to close down this one and open this one up. So here's the plane now. We've modified the plane sprite. We have the same plane GIF and all the other stuff to create the sprite. And then we're going to do this check. Now, why would we want to do this if not Pygame Mixer check? Why would we want that? Anybody? Anyone have an idea? Why would I want to do this check if the Pygame Mixer is active? Why do I care?
In case music files missing.
It could be. Problem with the sound, right? It could be that I haven't initialized my Pygame Mixer. It's a good check, right? It's a good debugging methodology. But that won't stop the sounds from, that won't stop, if I'm missing sounds, it won't launch this. Like it'll still launch. If I'm missing a sound, if I'm missing the yay.og file or the thunder or the engine or one of those, it's still going to try to play them even if they don't exist if the mixer is active. But if I forgot to turn the mixer on and it tries to play these things, right, it's going to say, it's going to actually crash your code, right, which you don't want it to do. So that's why this is really from a debugging perspective. That's why reason why you put it in, all right? Somehow if it's not available, let's say for example on your device, you can't initialize the mixer because you don't have sound on your laptop. It's not installed. There's no driver for sound. Well, then the mixer won't initialize. That's another reason to put it on. Like your physical hardware doesn't work, then this won't work. This is the same. Your position of your plane is exactly the same. But now what I'm doing is I'm initializing all of my sounds here for all of when I instantiate my plane, my plane is going to preload all my sounds because really my plane is going to be the thing that's colliding with everything else, right? So my avatar is going to have all my sounds preloaded when I create it. Now this is going to take a few more seconds to load your Pygame code, right? The more stuff you load into Pygame, the more classes you employ, the longer it takes for your Pygame window to load. Like you'll see a noticeable delay. And again, I'm loading the image from my plane, and every time I instantiate my plane sprite or my avatar, I've got my yay file, my thunder file, and my engine file all working. I'm also saying, as soon as I've launched my I instantiate my image, the only file that I want to play immediately is my engine sound, and I want to play it to infinity. I want to keep playing it in the background. So it's going to go. That's what it sounds like, right? Like my plane is on, right, as I'm going. So that's what's going to happen here. My island sprite's not going to have any sounds attached to it because there's nothing that happens here, right? The island doesn't collide with the we don't care about the island colliding with the cloud. We're never going to check that, right? It's going to pass underneath the cloud, okay? The cloud itself, it's going to collide with the plane, but we've already built in the collision sounds of the plane. So this is all the same. Okay, again, we're instantiating the three objects, island, cloud, and plane, right? And we're launching the file exactly the same way. Here's something where we're going to do a collision check here, but I also want to notice, where do we instantiate actually our mixer, right? Well, it happens usually right at the top, right? So here is where inside of our plane sprite is where we instantiate our mixer object. So we initialize our mixer right here. So when the plane sprite is created, we also create our mixer. We've actually, we pull the mixer and make it work, okay? But we're not going to do that we're not going to instantiate it more than once. I personally think this would be okay to do if you only have one avatar, or if you're only going to do this once. But I recommend to you that you instantiate your mixer outside of your class, and you do it inside your main, right? So that way it's instantiated. You launch your mixer, and you don't do it inside an object like this. Because otherwise, if I instantiate this object again, and if the mixer has already been created, as an example, it'll error out, or cause unexpected results. Okay? Let's take a look at this. And again, you won't be able to hear it, but I recommend to you that you launch this in your Aptana to test it. Okay, so you're going to see the exact same thing on your side, but on my side, I'm hearing the sounds. I'm hearing the roar of the engine.
Yay.
Yay. I'm checking for my collisions.
Yay.
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 Explosions. So I'm almost there. I've almost got the whole part of the game. I've got collisions, and I've got movement. Let's check and see how I do my collisions. And I do that with the objects inside of my main game loop. So here's my main game loop, and here's my collision detection. If plane rect, the rectangle around the plane, collides with, collide rect, the island rectangle, right? So if those two rectangles intersect, I've got a collision. And if I do, I want to play the sound file, the sound yay sound, the yay sound in my plane sprite, okay? And then I want to reset my island. I want to send that reset command to, as soon as I collide with my island, I want to reset it to the top of my screen somewhere randomly, right? If I collide with a cloud, same thing. I want to reset my cloud, but I'm going to play a different sound. I'm going to play the sound, the thunder sound, when I collide with it, as an example. And that's the only thing that's changed. Now, the one thing I do at the bottom, just from a cleaning up perspective, just like I take away my, or I show my mouse again when I'm done, and I stop my engine sound. I don't have to do that, I'll tell you right now, because if I close down Pygame, it'll keep playing. It won't keep playing the sound. It'll stop my sound as well, right? But from a housekeeping perspective, it's good to turn these things off because it could pose a memory leak on a mobile device. If you're going to program something like this on a mobile device, it's good to shut everything down after you're done. Shut your sound down. All the regular things, turn things back on that you turned off. Okay, so that's your collision. And we're going to go through it all here. Again, we've already talked about this. It says you may have to adjust volume to make sure the background sounds aren't too loud. And again, here they index something called Appendix D in the book on how to create sounds with Audacity. Now, we don't have the book, but my recommendation to you is you will have to adjust the sound volume sometimes with the sound clips you get. Sometimes they're inappropriate. You're going to get a sound clip that's way too loud. Like the background is like droning in your ears. And you want to kind of mute it a little bit. And there's functionality in Pygame with the sound mixer to reduce the sound so it's not as loud. Okay? So you may have to do that with your functions in Pygame. Or the better way to do it, instead of reducing the sound through Pygame, is actually to do it, adjust the sound through the sound file itself by going through something like Audacity. Load it up in Audacity, reduce the gain, and so on, and then respit it out as its own sound clip. So you don't have to do those extra commands. It's already done. The more commands and steps you have to do in Pygame, the more things, the more calculations your code is going to have to do, right? Which is going to slow things down potentially. Okay. We check for collisions. We use the collide rect method to check for collisions. Now this is one sprite colliding with another sprite. We didn't check groups here. Okay? And we reset the sprites. Now, and they say, well, why reset them? Why not just collide with them and then, because if you reset the sprites, right, if you don't reset them, it can cause a series of collisions. So example would be, and let's just see how this works. Here's a test for you guys. Go into Aptana, right, load up your collision, your mp collision.py, and take away the reset method from your sound. And you're going to see it's going to go, yay, 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 yay. Because every time the plane passes through it, it's going to continue to collide 30 frames per second. That's why you reset the method. But try it. Try it out. Go into Aptana, take that reset away, the reset method away and hear for yourself what it does. It's not the right effect. Right? I'll give you a second for that, if you're interested. So what we're doing actually is saying this. While you guys are doing that, I'll show it kind of up here. Oops, I launched the wrong tool. That's okay. So here's my cloud, right? And if you imagine, is there a collision here? Look up here. Is there a collision here? Yes, 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 yes. Every time I collide with my cloud, which I'm colliding with it as I go, it's going to produce that sound effect, which is not what I want. It's going to produce a cascading amount of sounds as we go. Just turn this off, which is not what you want, whether it's here or with the cloud. So let me load up the cloud sprite for a second, just for our demonstration. So here's our cloud sprite, and here's the background. So here's the cloud. So I'm passing through the cloud, and I pass through this much of the cloud. Bang, 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 bang. You're going to keep hearing that thunder sound every time as you pass through it, which is bad. So it's better just to reset this cloud somewhere on the top, right, as an example. And now your avatar is going to be down here somewhere, right? So when this island pops down onto it, it's going to reset somewhere on the top. And this cloud drifts into it, it's going to reset somewhere on the top, right? You don't want to continue exploding or having that collision. That's one possible way of creating what effect you could have. You can also, if you want to create a more complicated effect, you can create an animation in its place. So example is, let's say this cloud was in the cloud, but it was actually an enemy, and somehow you collided with the cloud, right? What you'd want to do is, as soon as it collides, you wipe those two objects away, your ship and the cloud, create an animation, and then reset everything. Right? That's the place to put the animation effect in. And you'd have to time the animation with the explosions. That's the challenge, right? So your sound effect is going to have to kind of go together with the explosion effect. And that's the challenge you're going to have to, as you put things together. Right? You may have to retime things or create your own explosions. The explosion sound clips. So who was able to recreate it? Did you guys try it? Take away the reset, run your code, MP collision. Did you try it? And then what it'll do is it'll create those multiple sounds. Okay.
I had that problem with my last time. So.
And you fixed it. All right. Let us go back to our code. Okay. The next part is, I think, very, very important. It's building a scrolling background. Okay? What I want you to think about, and I'm going to give you a little bit of a challenge for today's class, right? To see if you can pull this off. I'm going to ask you to create a parallax scrolling background. Okay? Has anyone heard of a parallax scrolling background? We did it kind of in Java, right? The way you do it is you create a background scrolling object. I'm telling you in advance what I want you to do. So if you want to listen and start doing it now, you can go ahead. I want you to create a scrolling background where the background itself, way in the background, it scrolls very, very slowly. Like, I don't know, 1 pixel or 2 pixels at a time, right? Then there's going to be another object that's lower, a lower part. So there's going to be a big background to take up the whole background. It's going to scroll really slow, right? There's going to be another object in the background, a second object that scrolls much faster and is layered on top of the scrolling background. So it's going to look like there's two things scrolling. They're going to go in the same direction, but one's going to move faster than the other. Then there's going to be a third one right in front of you, all right, much closer, that's going to scroll the fastest. So you might have a 1, 5, and 10 delta value that you're going to use for scrolling. But there's going to be 3 objects that are going to be scrolling in the same direction at different speeds to create that parallax effect. The challenge is to find the right sprites to layer one on top of the other to create that parallax view. So the background, the big background, the first layer, or the sprite in the background, has got to be something that's going to be larger. Like, for example, a backdrop with maybe mountains in the background, way in the back somewhere. And the one closer might be something that's happening much closer up, buildings or something like that. Then the one right up might be the surface, your ground that you're scrolling on, right, that you're on, right? Because that's the closest object. That's the object that's going to be running the fastest. So you're going to basically see an object in the background that's slightly moving, not as fast, maybe like 1 pixel per frame, where the other ones are moving much faster. So it's going to look like you're passing. It's going to give the illusion of perspective or depth to your game. So that's going to be your challenge for today. So if you want to start doing that, go ahead as I continue talking about the scrolling background here. Okay? So one of the things it says is arcade games frequently feature an endless landscape. Well, how do they do that, right? So they create a landscape, a sprite, and what they do is they repeat the sprite. It gets to a certain position, and then we flip it back to, where the, at the beginning of where the sprite is. We'll look at that. Okay? So the background image is actually a sprite, like we talked about. Okay? It's 3 times taller than the screen in this particular case, but you can make it as many times taller as you want. Okay? And for MailPilot, it's only 3 times. So what they've taken is they've taken the original sprite, and they've actually dragged it out 3 times as big. So instead of it being 640 by 480, it's 3 times 480 for it to be that long, right? And then what they're doing is they're scrolling down, so it takes the whole background takes 3 whole screens, if you will, to go down, and then they repeat it. Okay? The top and bottom parts of the image are identical, so they kind of loop, right? They kind of connect together, right? And we're going to see that. And then the image scrolls repeatedly, swapping the top and the bottom when it reaches the edge. So as it moves down, and the top part of the object gets to the top part of your screen, it resets. Okay, we're going to see that, how it works. So some tricky stuff we have to do. So here's an example of what it is. So here's a good view of it. So the red area here, right, is our viewable area. This is our point of view. Okay? Then we have a sprite that's sitting larger than the screen. Right? The sprite itself is it starts up here. Then it starts scrolling, and finally the top part of the sprite, this part here, gets to the top part of the screen. And when it does, we reset it to here again. And it's an endless loop that goes like this. So it gives the illusion of this endless background. Well, you can do the same thing with our parallax scrolling view, but be careful because again, the sides of it have got to kind of loop together. They kind of connect. Like for example, if you have a sun in the background, right, that could be its own sprite. I would recommend not putting the sun in the scrolling background, right? Because the sun itself, it doesn't move. It just kind of hangs there, right? While the background moves. Okay? So again, these are the things you can kind of think about, how to create elements that you want to include. The other thing is that in our scrolling background, in this particular case, it takes up the entire width of the screen. It does not have to take the entire part of the screen. Part of your background can only take a portion of your screen to scroll, right? Because you don't need the entire background to scroll, just part of your screen to give that illusion. Okay. Let's take a look at MP Ocean to see how this little refinement is going to work. So not this one. Actually, I'll load it up here just to show you it. So here's our ocean sprite, right? And if you notice, it's pretty darn long, right? In fact, if you look at the actual width of it, or the height of it, it's 1,440 pixels. But our screen height is only 480 pixels. Okay? And here's the top of the ocean, if you look very carefully. And here's the bottom of the ocean. And they kind of connect. Here's this little squiggle here, right? And the little squiggle here doesn't really impact the top squiggle. It kind of looks like the ocean is a bunch of these little squiggles, right? But as this thing moves, it gives you the illusion that this is a big ocean. That's all it is. So it's going to scroll like this. Actually, it's going to scroll the other way. It's going to scroll like this. Watch. So I'm going to scroll it up like this. So here it is. My ocean's scrolling, scrolling, scrolling. It's going to keep scrolling. It's going to keep scrolling. And all I'm doing is I'm moving the ocean sprite down. So it gives that illusion that it's actually scrolling down when it's not. When it's not at all. Okay. And if I was going to layer my islands and everything else on top of it, so here's my island, okay? The key here is that if I put my island on the ocean, right, how fast should my island in the ocean move? Should the ocean move faster than my island? And the answer is no, right? The island and the ocean should theoretically scroll together, right? It should kind of stay stable like this. You don't want your island moving like this on your ocean because your island doesn't drift, right? The island's got to stay stable, so that's not going to move, right? Your clouds are going to move fast in the ocean, but my recommendation and my guess before we even go to the code is that the ocean is going to move at the same rate as the island, which is 5 pixels per frame. My guess. Let's take a look. So here it is, mpocean.py. I got my plane with all its sounds. I got my yay sound, my thunder sound. In this particular case, I'm not sure why, but the author didn't include the engine sound on this particular iteration. That's pretty annoying. Here's my island sprite, same as before. Here's my cloud sprite, same as before. And now I've got my ocean sprite, and my ocean sprite's going to load up my ocean.gif, right? I'm also going to have I'm going to create a rectangle. I need to use this getRect method so I can check. I can do boundary checks. Remember, the getRect method is not just for collisions, but it can also use to check the top, the bottom, the left, and the right boundaries of an object, right? Where they are, right? And again, like I thought, my delta y, the change in y, is going to be 5, which is matching with the ocean. I'm going to call the reset function when I first instantiate this object. And what does the reset object function do? It says the bottom of my ocean, the bottom of my file, is going to be at the bottom of my screen. So I'm going to align the bottom of my sprite with the bottom of my screen. That's where I'm going to start off. Okay? And then what I'm going to do is in my update, I'm going to say if the bottom, I'm going to actually add 5 pixels to the bottom. I'm going to keep scrolling from the bottom down, right? And if my top is greater than or equal to 0, so if my top aligns with the top of my window, I'm going to reset it so that my bottom is at the bottom of my window. That's all I'm doing. So I'm just going to reset that screen very quickly. And it's going to happen on my update. So it's going to happen faster than my eye can detect it. Now, here's the trouble. If your scrolling background is drastic in terms of the one side and the other, you're going to see a theme or some kind of weird flash. It's going to go back to the beginning, right? You don't want that to happen. You want it so that there is a natural transition between the top of your, or the left of your object and the right of your object, okay? Because if there's some kind of drastic transition, it's going to look ugly. It's going to look like a jerky action, like things are back to normal again. It doesn't really look good. So you're going to have to test that when you do your, when you create your game. So here I'm instantiating my object, my plane, my cloud, my island, and my ocean. And again, I'm using ordered updates to make sure that my ocean is first. So that's the lowest level, right? And again, I would do this for your parallax scroller. If you're going to create your parallax scroller, you want to do the same thing. You're going to have the back part of your scroller way in the back. That's going to be the first thing you're going to load up. Then you're going to have the next part of your scroller here, and here, and here. And this is going to be almost like, if anything, you should create one big sprite group just for your scrolling background that has nothing to do with the other sprites. All it does is update the scrolling background, because there shouldn't be any interaction with your scrolling background and the sprites, theoretically. Your avatar and your objects and your enemies. But in this case, we have our ocean first, then we have our island on top of the ocean, then we have the plane on top of the island, then we have the cloud on top of the plane. Because the plane is actually flying underneath the clouds in this particular case. Okay, same kind of game loop. We're still checking for collisions the exact same way. Nothing else has changed. The only thing we're doing is removing our background. So we've almost got everything we need here. Let's take a look. So here we go, right?
Yay.
I collide. I've got my sounds. You can't hear them, but they do exist. I reset my objects when I make collisions.
Yay.
And as I scroll down, you don't notice that the screen is going to reset. Like here's my my ocean background, and it's not like it's going to reset my ocean that you're going to notice a reset.
If you make it a little bit bigger, you notice. I made it bigger to text my size.
And you do. You'll notice it because it's not as it doesn't repeat properly. Okay. But really, all we're doing is the background. If you notice the speed of the island. Here it is.
Yay.
And the speed of the ocean happens exactly the same way. Same speed.
Yay.
Right? Okay. So almost complete. We've got our plane. We've got our clouds we have to avoid. And we have our islands that we have to go on top to get points. That's what we're doing here. A, B, C. Okay? And our ocean background to create that effect, that illusion. Okay, we're going to kind of script through here. But maybe one cloud isn't really challenging enough, and I want to replicate. This is the great thing about using classes. I want to replicate the number of the cloud sprite. I want to make multiple clouds, not just one cloud. Okay? So I want to make it more challenging. So all I have to do is add multiple clouds to my group and update them randomly. That's all I need to do. So let's take a look at mpclouds.py. And this is the power of classes and objects as opposed to writing things procedurally. Plain sprite's not changing, right? My island sprite's not changing. Here's my cloud sprite. That's not changing, right? I haven't changed this at all. Everything's exactly the same here. Here's my ocean sprite. I'm not changing that. But when I start instantiating, now I start with multiple clouds. Cloud 1, Cloud 2, and Cloud 3. And they're using the same cloud class as their framework or blueprint, right? So I've got multiple clouds here. Now, here's where it's really, really cool to have different kinds of groups for different objects. So I've got my friendly sprites, the sprites that I cannot collide with as an avatar. I can't collide with myself, right? And I can't collide with the ocean, not in this particular game anyway. And I can't collide with an island, right? I can't collide with these objects. But I can collide with this cloud sprites group because all the groups in all the clouds are in one group that I'm updating at once, okay? So here we go. Here's this, the regular game loop that we're playing. And now I'm checking my plane, right? If my plane collides with my island, right? I make the play sound. I make the yay sound. Yay! I get the points, right? Eventually. And then I have this other little line here. I say hit clouds, a variable, is equal to pygame.sprite collides. I'm checking this other method, right, with my plane and my cloud sprites. So I'm saying if my plane collides with any of my clouds, any one of them, right, I'm still going to do the resets that I'm going to do normally, right? I'm going to say if hit clouds is true, so I did collide with a cloud, I'm going to play my thunder sound, boom, or whatever, right? And then I'm going to have a loop for every cloud in the clouds that are hit, whatever that cloud is. I want to reset those clouds. So if I hit multiple clouds, which is possible, if the clouds intersect, because the clouds aren't going to blow up on themselves, or they're not going to, because they can intersect. There's going to be multiple clouds on the screen. But I can collide potentially with more than one cloud at the same time. I only want one thunder sound, and I want every cloud that I collide with to be reset. That's what this does. All right? Well, what I have to do, because I've created two groups, is I have to update those groups and redraw them on the screen separately. So I update and I draw. I update and I draw. And if you notice, there's no clear. I don't have a clear function here. We're going to talk about that. So let's just try it now. So now we're almost there. We've added multiple clouds. They're the exact same shape. And if I collide with both of them, right, I can have multiple clouds collisions. There it is. Sometimes it's possible to collide with both at once, or almost at once. I want all of the clouds that I collide with to be reset to the top of the screen. Okay, and I'm doing that with this one line right here. So I'm saying I've hit the clouds somehow, right? This hit clouds variable is going to get which sprite that my plane collided with. That's what it's going to do. It's going to say my plane's collided with a cloud, right? Whatever cloud sprite it's collided with, take it and put it into this hit clouds variable. And if my hit clouds variable is not null or not empty, right, then play the thunder sound once, right? And then for every cloud, because I could have more than one collision at once, in my hit clouds command, reset the clouds. Okay, let's take a look at it one more time. Does it reset all the clouds every time, or just the clouds that are hit? Just the clouds that are hit, right? But if I hit both clouds somehow, and I can try and do that, sometimes there's that possibility. I can't do it. It's hard to do, but you can get both clouds colliding with your ship at once. I want both those clouds to be shifted to the top. So we're almost there. We're getting there. We're getting closer and closer. And as you see, we're building our mail pilot game one step at a time. right? We're moving from one set to the next, right? We're refining our game as we go. All right. We talked about this. Put the clouds in their own group. We're checking for multiple clouds collisions because it's possible, right? We have multiple cloud collisions. Sprite collide returns a list of hit sprites or the value false, right? That's what it does. So if the false value means that there's no collision, right, for this particular check in this frame, okay? And this is the key. If hit clouds isn't empty, play the thunder sound and step through the hit clouds list and reset any clouds that were hit, if any. Why is this important? If I have a gun and I'm making enemy objects, and I have a gun that fires bullet sprites, bang, 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 bang. I'm firing bullet sprites, all these things. Sometimes my bullet doesn't necessarily have to disappear. If I have a mega bullet that can hit more than one opponent, when my mega bullet collides with my opponent disappears, maybe has an explosion, but maybe it keeps going and hits another guy, right? There's some games like that where you can have like this mega bullet that doesn't explode, right? You can have that, but typically when you have a bullet, it hits a guy, it doesn't hit the next guy too, right? Unless you have some kind of shotgun. Right? So think about this as the same kind of idea where you have multiple enemies that are going to be hit by your avatar or your avatar's weapons. Okay. So the game is basically done, but now we need to kind of provide feedback to the user on his progress. So how we're going to do that. So we're going to, at minimum, we're going to count how many times the player has hit each type of target, right? And this will usually relate to some kind of game-ending condition. So if the user has health, and I've asked for you in assignment number 4 that the user either has a health line or some kind of lives. So I have 5 lives, 3 lives, whatever. And every time my ship gets hit by the enemy or a cloud or whatever, then I lose a ship, right? Let's take a look at MP score to define that. So here's MP score. I've got my plane, no difference, right? Different. I got my engine back now, and it plays forever. Andy Harris has put this back into this iteration, right? I've got my update. Here's my island, right? All this is here now. Okay, here's my cloud. I'm not changing this. But I am doing something different. Here's something interesting, right? I am doing something different with my cloud than I did before. I've got this new inflate underscore IP object for my cloud, right? So if I hover over it and find out what it is, right? Here it is, inflate IP. Usually what it'll do is it'll give me the what this function does, right? This inflate IP object, right? If I want to see what it does, we're going to define what it does. But it says minus 20 to 20, right? That's what this thing does, right? So it's going to, we have an inflate object, some kind of method that we're going to be using. Okay, let's take a look. Here's our update. We're going to reset everything the way it was, right? We're going to change our dx and dy value the same. But this time, every time, and this what this inflate object is, it's going to increase or decrease the size of the cloud randomly from minus 20 to minus 20. Let's take a look and see what that is later on. Here's our ocean. Everything's the same, right? We've actually got some, instead of checking with relative values for the size of the screen and so on, now we've got hard set values, 1440 for the size of the screen and 960 for the top. Okay, so they've actually changed these values here. And now I'm doing something called a scoreboard. So I've got my scoreboard class. My scoreboard class is going to define my character or my avatar's life and score. Okay, so right now it starts off, I have 5 lives. My score starts at 0. And I have a font that I'm using, a system font, right, with a score with a size of 50 points. So I've got a 50 pixel or 50 point font that I'm using. And on update, the text of my font is going to be lives, whatever the lives are, score, whatever the score is, right? I'm going to update that, the text of that, of the object. And then the image is going to be a font that I'm going to render, right, with the text, and it's going to be red and green, which is going to be a yellow text that I'm going to put up, right? And I'm going to define borders around my object as a sprite. It's going to appear at a certain point on my screen. Okay, so this is my scoreboard right here. Okay. I haven't really defined where it's going to go yet. I'm going to tell it in a second. Okay. Everything else is the same. My background, here's my screen, my plane, I've got my island, I've got multiple clouds, 1, 2, 3, I've got my ocean, and I also have a scoreboard, and my scoreboard happens and instantiates last. Okay? I got my friend sprites group, it's my ocean, my island, and my plane. My cloud sprites group, it's all my enemies, cloud 1, cloud 2, and cloud 3. Then I have my score sprite, which is just text, which is it's got its own group. Okay, so I've instantiated all these and put them inside their respective groups. Excuse me. Okay, here's where I do my checking now. I check to see if my plane collides with my island. If it does, I play the yay sound, I reset my island, and I increase my score for my scoreboard by plus 100. So I give myself 100 points. Okay? That's what I'm doing here. So my scoreboard is just a class that's keeping track of my score right now and changing my text of the sprite itself, my font. Okay, hit clouds. I check to see if my cloud has been, or my plane has been hitting a cloud. If it does, I play the thunder sound. I take away 1 life, right? Here's a life. If my lives are less than or equal to 0, I print out game over. This print statement doesn't print like on the actual screen. It prints here on my console, right? My lives are reset to 5. My scoreboard is reset to 0. And then I reset all the clouds I hit. That's what this thing does. I update my friend sprites, my cloud sprites, and my score sprite. I draw them back on the screen, and I flip the screen and put everything back on. Okay? And again, where does my font exist? Where is it going to be defined, or where is it going to show up? Right? Here's where we define my scoreboard, right? And when I define my scoreboard, it's got to go somewhere. Lives, score, and so on, right? If you don't define it, where does it start? Well, it starts with 0, 0 as a default, which is top left corner of your screen. So at the top of your screen, you're going to have lives, score, and so on. Okay? And again, this is the color. So let's take a look at this one. So I'm running this one. So top left corner of my screen, it's crashing, 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 right? And then when I get to 0, right, it redoes my score back up to 5, right? If I hover over an island, I get 100 points. But every time I lose lives, all I'm doing is I'm checking score to see if it goes back down. If you notice on the bottom here, I get my output to the user saying my game is over. So I've lost enough lives. So I'm actually checking my collisions here. Here's 100 points. Here's, I missed that one. Hold on, I don't want to get hit. I'm avoiding getting hit here. Oh. Okay. Don't spawn like what? This one here spawns close to the middle or whatever. Yes. It looks like that because remember, it's spawning and then it's moving it within the same frame. And you can change it so that the islands spawn off screen, right? So they slide down, right? Which is the way to go, to me, right? But these are the basics. What we're showing you here is basic points. Yes, Steve. Yep.
Can you assign them to like different classes, like cloud, big cloud, small cloud?
You could do that. You can do big cloud, small cloud, and then each cloud would have a different size. You could do that.
I just mean, like, can you group you know how you had 3 different clouds?
Yeah, you could do that.
Do that group up with 3 different things?
So the question is, if you had different cloud classes, right, could you still put them in the same group? I think is what your question is, right?
Yeah, like enemy 1,
And,
2, 3.
and if enemy 1, 2, and 3 had different sizes and different properties, yes, you could. You could put as many like or unlike sprites as you like within a group. Okay, and they would all update, they would all perform their update method at the same time when you use the update. But let's take a look at what we've done here one more time. So we got the cloud drifting as an example, right? Clouds all look the same to me, right? There's no difference in size, right? But they do look a little smaller than the clouds originally looked like. Let's take a look. If I take away this line here, this is the only change to the cloud class right here, right? This self.rect inflate IP, right? And I went minus 20, minus 20. Are the clouds any different? They look exactly the same to me.
Yay. Yay.
Really no difference. Okay. So again, planes count how many planes or user lives remain. Score counts how many clouds the player has hit, and so on. Actually, it's the other way around. And both variables are stored according, as an attribute in the scoreboard class, okay, which we talked about and went over. We added the scoreboard, and again, because we didn't define where the text went, it went in the top left corner of the screen. Okay, we have to manage the game ending condition, and we do. We say, for now, we just kind of output to the console saying game end. So my lives went to 0. I got to end my game somehow, and I throw this game over output onto the screen. And I'll reset everything back to the way it was. Okay, here is where we're going to add another screen, if you will, to the game. So this is the beginning game with the instructions. Okay? So most games have more than one state, if you will. That's what they say here, right? So we have the initial state would be your start screen, right? Then you have another state, which is your gameplay screen. And remember, in assignment number 4, I asked for a third state, which we don't have it here, called the game end screen. I want you to actually create it's another state altogether. In this case, all we're doing is going from state 1, which is the intro screen, to state 2, which is the gameplay screen, and then back to state 1. That's what this does, because the intro screen and the score is all included in one, right? I want you to break that out a little bit for your assignment number 4, which I stated in your requirements. Again, for simplicity, MailPilot only has 2 states. I'm asking for 3 states with your game. With your assignment number 4 and with your project number 1A and 1B, there's 3 states at the minimum. Okay. So we're going to talk about state transition diagrams. But again, we talked about this. States are really part of your storyboard, right, if you will, or screens, right? So we're going to start off as, the first state, and we're going to talk about how it flows into the next state for your code, right? So here we go. So here's where we enter, right? Here's a diagram. We enter into here. We go into the intro screen. We play the game. Here's the next state, right? We keep playing until there's a losing condition that's fired or triggered, and then we go into this lose state back into the intro. When we want to, from the intro, we have 2 options. We can play or we can quit. Those are the 2 arrows that come out of intro, okay? From the game, we can lose or we can keep playing. If you notice, there is no quit condition from the game. That's not really true. In reality, MailPilot, you can just exit out of it and you quit as well. So there actually is another quit arrow that should come from here to the exit, okay? But really, this is a transition. In your case, you're going to have 3 states. You're going to have your intro, you're going to play the game, and when you lose, instead of it going back to intro, it's going to go to this third state down here, which is going to be a game end screen, which is going to give you the option to play again or exit out, and also give you your high score. Okay, totally different screen. So that's the difference between MailPilot, one of the differences between MailPilot and your assignment 4. Okay, so how do we do it? Well, it says here, the easiest way to manage game state is to think of each major state as a new idea framework. In other words, it's got its own game loop. It's got its own screen, right? You're recreating the top level window again, right? That's what you're doing. Now, I was speaking to some students during break, and one of them said, well, what if I want to include a video, right, in as my game state, one of my game states? Like I want to show a video, like almost like a cutscene. That's okay, but Pygame really doesn't do cutscenes so good, right? So you may want to use another framework like PyQt or Coco Studio or something else to show your video. And then when that's done, when your video is over, then you switch back to the Pygame state, the next screen or whatever. So you have, basically what you're doing is you're moving from one screen, you're creating the screen, killing the screen, and creating the new screen, killing that screen, and then creating the new screen. On a mobile device, however, this is where it gets tricky. You can't really destroy the objects so much because you might end up, you could, but you might end up leaving the game altogether. What mobile devices a lot of times do is they layer one state on top of the other. We're not doing that here in Python. We're creating a state or the screen, we're killing it, we're opening up a new one, we're killing that, we're opening up a third one. Okay? Let's try and see how that works. So let's look at the design of MP intro, because we're going to create an intro screen. So again, most of the code previously in main, right, we're going to put it in the game function. We're going to create a new function called game, okay? And then we're going to have an instructions method or function that's going to include the entire frame, and its own framework for the instructions, its own game loop. So here's my instruction screen. It's going to have its own game loop. It's going to look different. And here's my other loop, my other game framework. It's going to have all the gameplay. Okay? Main, all that main now does is control flow and access and variables passing between my game screen and my instructions screen. That's all it does. The instructions function and the game functions are the ones that control the loops or the game loops within them. Almost like self-enclosed or encapsulated screens of their own. Okay? This is the one way you can do it. There's other ways too, by the way. But this is the simplest way. Okay, all the game code is moved to game. That's what we've done here. And the return the score back to the main function so it can be reported to the instructions. Okay? So game actually has an output. Game has a return, right? And what we can do now is instructions has to take a score as most likely as an argument. Let's take a look at that. Okay. So I'm going to actually go to my instructions screen here. So here's mpintro.py, so I can show you this stuff without talking about it. So the same sprites we had before are still there. Here's my plain sprite. I'm going to maximize it this time for us viewing it. Here's my plain sprite. Everything's exactly the same here. I haven't changed anything. Here's my island sprite. Haven't changed anything here. Here's my cloud sprite, right? Haven't changed anything in here. Everything's exactly the same. Here's my ocean sprite, same. My scoreboard sprite, same. Everything's the same. Except, now when I go down to main only has this little bit of work to do, right? I've got a little while loop, right? I've done this almost like an outside loop, or we're going to loop a loop within a loop here. We're going to instantiate in a second. So our outside loop, the main game loop, if you will, is right now we're not done playing. Okay, our score initially starts at 0. This is kind of almost like a global variable, or if you will, I'm not going to call it global, but it's like almost like the variable for the game itself. Okay. So while I'm not done playing, right? My done playing is equal to the instructions. So I'm going to get if I'm done playing or not from the instructions screen. In your particular case, right, you're going to get this the state whether you're done or not from your game end screen. Okay, when you're creating assignment number 4. But for our purposes, for MailPilot, we're getting this output from the instruction screen. We're going to pass into it, like I thought, the score argument, right, into the instructions function, right? But if we're not done playing, I want to get my score from my game function. So here's my game screen. So let's take a look. my game screen look exactly like my old main method. I start up with a caption, mail pilot, MP intro, add intro to the game states. I, start off the screen and so on. Here's my caption. I have my plane, my island, my cloud. I do all the same kind of stuff I do with my clouds and everything. I do my hits. This time, though, my keep going is equal to false if my lives become less than 0. So I actually exit my game loop. So once I finish when I die, right, I leave my game loop. Okay? When I leave my game loop, here's where it comes down here. I stop my game, and this is where I stop my engine, right? I reset my cursor to true, right? And then I return the score from my scoreboard that I have in my game loop back out to the main function, which is down here. So I return my score. Here it is. And now within this loop, I go back. I'm not done playing, so I take the new score and I fire it into my instruction screen. Okay? In my instruction screen, here it is. All I have is 2 sprites. I instantiate the plane sprite. I instantiate the ocean. So the ocean is there, and it's moving just like it normally would. I have an all sprites group, ocean and plane, and I create my font, right, with 50 size font, right, system font, the default one. Here's my instructions that I create. That's going to take up, it's a list of different text values. Okay, here's a list. Right? So a big list of text values. And then what I'm going to say is, here's my instructions, a big list. My labels is going to be an array, an empty array, right? And then what I'm going to say is this. For every line, so each of these list items basically are lines. Every line in my instructions, I want to create a temporary label. I want to render it, as an example, on the screen. And I want to append my label, right? I'm going to basically append this big, onto my label, all the lines of my instruction, one after the other. I'm going to kind of add them all into this temporary label, okay? And then inside I'm going to have my own game loop for my instructions, right? Here it is. And the only thing I'm going to listen for is my keep going. I'm going to listen for my mouse button down. If I click my mouse button, I'm ready to go to the next screen, right? I'm going to also listen for an escape key, right? And then I'm going to draw my sprites on the screen as normal, update everything as normal. And what I'm going to say is this. For I, in range, the length of the labels, I'm going to blit them, each label on the screen, but I'm going to give myself, I'm going to increase my, where I'm going to print the next label down the height of my labels in pixels. So I'm going to basically space down 30, space down 30, space down 30 every time I print my new label for my instructions. That's all I'm doing here. Okay, and then I'm going to stop my sounds from my engines. I'm going to stop my visibility, and then when done playing, I'm done playing here is true. I'm going to fire this back out, right, to my main. And if I'm not done playing yet, I'm going to keep on playing the game. If I am done playing, I'm going to exit out of here and I'm going to finish my game. Okay, so done playing from my instructions. Basically, if you notice, okay, done playing is going to be basically a variable that I'm going to update. Here it is, done playing is equal to true, and here's done playing is equal to false, right? It's an additional flag for my overall, the outside game loop of my game, right, that I'm going to set within my instructions. So I'm going to allow my instruction machines to say, okay, I'm done, exit. You want to break this out when you do your assignment number 4 and put this overall, exiting the main game loop, inside your game end screen. You don't want this in your instruction screen. Your instruction screen should only allow you to go to the game, okay, which, like I said, in your assignment number 4. So let's see how this works. Again, we create 2 different screens now. So here's screen number 1, my instruction screen, right? I can move my mouse left and right. It looks like my background scrolling, but I don't have any clouds because I didn't instantiate those clouds in my as objects in this game loop. All right. So this is my first screen. If I click somewhere on the background, now my gameplay screen is launched, and now I can actually play my game, okay, and accumulate my score. When I'm done, it passes my score. Here it is up here. My score is passed back into my instruction screen, and now I'm in that loop. Okay, so I have really two different games going on, right? The first game screen, if you will, is my instruction screen, and I close it down, I finish it, and launch my other one in the same position that I had my the one previous, right? Okay, so let's take a look. So if you notice, a couple things. My instruction screen is here, right? And here's my gameplay screen. That's here, right? But way at the top is where, and this is almost like a global variable for my game, which, by the way, there's other ways of doing this. The author did this for simplicity's sake. His screen, his top-level window never changes, right? His top-level window stays at 640 by 480. The only thing that changes is the background. The background is rewritten, right? So here's my background sprite, right? As an example, it fills up with different things. The background changes according to which function you go into. So, again, going back to your container objects like we talked about before, I'm going to go back to fireworks for a second. So here's fireworks, right? And let's just get rid of this stuff. This is my top-level window, let's say, right? Well, I have this other object, other container object that sits inside of my top-level window right here, right? This object, which is the background, this is the only object that changes, right? Not my top-level window. My top-level window stays. It's created at the top of my code. So my functions for game and instructions doesn't change my top-level window. It doesn't recreate that. All it changes is the background surface object, which is the container for both my game and my instruction screen. Okay, that's what it does. You don't have to do it this way. You could shut things down with Pygame and restart them again and reinitialize everything. You could do that. Okay? There's many other ways. For example, you might start off with a screen that's rectangular, right? And then if you notice, some games start off as a rectangular screen, but then your top scroller, so now the screen it's a different size. You can do that too. You can change the size of your screen so it doesn't have to remain the same as your top-level container. Your top-level container can be defined, so created and destroyed, and you have to destroy or exit out of your of that top-level container without exiting out of your Python, right? Without exiting out of Python, you have to create and destroy your top-level containers at different states. But that's more challenging, and that's why they haven't included it in here. Okay. Let's go back to this. So we talked about the instructions. We talked about rendering the instructions. This is really key again. We're going to create a loop to blit out or display the instructions. And we're doing this through the loop. It's going to start off at they use I, right? But it's going to be for I in the range of how many labels there are. So if I have 10 lines, as an example, in my instructions, for every line, it's going to add in 30 frames. So, or 30 pixels. So I'm going to have my first instruction is going to be printed at the top, then 30 pixels down my next one, and 30 pixels down my next one, and so on. It's going to add that in. Right, but it's going to be, this is the X value. So my X value is 50. That's where it's going to start printing it off. And the next one, the Y value is going to go down by 30. There's different ways of doing this. This is just one way. Okay. Event handling, all we're doing here with the instructions is we're listening for a mouse button down. So as soon as the mouse button is pressed, then, we have these two flags. One of them is keep going is equal to false, right? Means I'm going to exit out of my game. This is exiting the actual game itself, right? I'm going to quit Pygame, right? Done playing, right? Done playing is true, which means I'm going to continue playing as long as my done play. This is actually a bad name for my flag. But there's two flags. The done playing flag is the flag that exists outside of my other external functions, outside of my game function and outside of my instructions function. And it's the flag that I look for on the main function to say, hey, am I going through different states? Am I changing from my game state to my instruction screen? Is the player still willing to play, or does he want to exit the game? That's what this thing is for. Okay. And again, I'm flowing instructions, I'm flowing arguments through the functions. I'm kind of putting an argument into the function instructions, and I'm getting a return value for each of my functions that return information back to my main control function, which that's what I'm using my main for, to control the flow of the game. Okay? And that's the new main function like we talked about before. So that's really it. And it really, up until that point, what we've shown you up into this state here is a couple of changes. Okay, what have we learned? We've gone through all these different phases of MailPilot, right? Until we get to the final MailPilot version, which is mailpilot.py. Right. So here's mailpilot.py, and it includes all of those different changes. In fact, it's almost identical to the instruction screen. Okay. Now this would be, and I'm going to be honest with you, how many versions do we have? We have MP Clouds, MP Cloud, MP Collision, MP Intro, MP Island, right? MP Multiple Clouds is another one, right? They've done. MP Ocean, MP Plane, MP Score. Those are all versions of your code. 0.1, 0.2, 0.3, 0.4. You're almost at version 1 here, right? And then at version 1 is your mailpilot.py, and you might go to version 1.1. Once you get your mailpilot.py working, you may be going something like this. Okay, but now I want to add in multiple levels. How do I do that? Well, level 1 would be its own function, right? Level 2 would be its own function. Level 3 would be its own function. And you can have each level looking different than every other level, right? With different aliens or different challenges you can have, and so on, taking up the exact same screen, right? So then, right, it's easy for you to plan to do multiple levels, right? What you do is you create different objects, different enemy objects, and all that kind of stuff ahead of time. Remember, all I'm doing is reusing the classes that exist in each of the different levels. I don't have to recreate the classes. I'm just instantiating new objects based on those classes, right? So again, each level is going to be a self-contained little program of its own, if you will. Okay, that's all I'm doing. Okay, that is definitely one way of doing it. Now, the other way of doing it was, I told you this before, if you didn't want to go to multiple different screens, so one level, one screen, we also talked about it gets harder as you go, right? So you have one big level, right? And as you go to level 2, there might be a timer you might set up. This is an option B. Okay, option A would be different screens, different levels. Option B, harder as you go, right? You get more enemies. Different challenge, different enemies are instantiated, and you're on that level as you get to a certain point, right? As an example, it looks like one big level. Different challenges, and so on. Places where you can save and load and all that kind of stuff, like a milestone. You can do that with one level. Option C, ahead of time in your instruction screen, you choose the difficulty. So what are you choosing when you choose difficulty? You're choosing different screens, right? You're saying, I want to go to screen 1, and I'm going to play that difficulty for the whole time, right? And it's going to have, an example, you can have a bunch of variables for that screen number 1. Like example, you might have less lives. You might have, for an easy difficulty, you might have a lot more lives. You might have, your bullets might do more damage. You might have less enemies for your easy, right? For medium, same screen, one big screen, right? Medium, you could have, less life. Your bullets do less damage, and you have more enemies. And for hard, as an example, it's the same. It just gets harder and harder, less and less resources, let's say. Or you could add different monsters. Different boss monsters might appear early, like in medium or hard, right? That's another way. Or you could combine them. You start with an easy. You also go from level 1, level 2, level 3, and you have a boss level, level 4, as an example. And you can do it with medium and so on. I would give you a bonus for that if you did both. If you kind of combined both methodologies, right? So you have like easy, medium, and hard and extreme. And then you also have level 1, level 2, level 3, level 4, if you can actually get to them, right? But with this, for project number 1A and 1B. But my recommendation to you is think about your project 1A, 1B now, right? As you're building this stuff for your scroller, if your scroller is going to be the basis of your project. If it's not, use the scroller as a way of learning what you can do for your project number 1A and 1B. Okay? So that's really what we're talking about here. Next week, we're going to talk more in terms of animation. So next week's a really important class as well, as we talk animation. We're going to talk animation over a couple classes because there's a lot to talk about with animation, sprite sheets and so on, right? So we're going to get more complex, and we're going to build a game engine by week 10, right? So next week, obviously, is the break, right? We're not going to come together. But the week after the break, we're going to start talking about animation. Okay. So who's done their successful parallax scroller as you guys been working? Anyone did that while we were talking?
I was going to do that.
You're gonna?
I'm probably going to still do it.
Is anyone working on it? So we have a few minutes. I want to give you some time to do it now, right? So I'm going to do that. And while you guys are doing that, I'm going to pause my recording here, and I'm going to see if I can find some assets to help you guys out.